Hello and welcome to my channel. Before we get started, I am instructor Allison, and in this physics video tutorial we want to find the current using superposition theorem, and that is the current that flows through the 6 ohm resistor. So the first approach to this problem is to make sure we shut down one of these 2 voltage sources. Either you shut down this first one or you shut down the second one. Whichever one you want to shut down is okay. When you shut it down, you replace it with a short circuit. If it were to be a current source, then you just open the circuit. Alright, so if you understand these two things I have said, now for us to continue in the solution of this problem, the first thing we need to do is to shut down this 10 volt source and find the current that flows through this 6 ohm resistor due to the 6 volt battery source. That's essentially what we need to do. So to shut down this 10 voltage source, we need to replace that with a short circuit, and that means we'll be having something like this. In redrawing the circuit, we have this. We just sketch this, and then we have this 6 ohm resistor. Okay, we have also this 3 ohm resistor. Here is 6 volt battery source. So here we have the 6 volt battery source. We have here to be 3 ohm resistor. We have here to be 6 ohm resistor, and this is 12 ohm resistor. Alright, so the essential thing we need to do here is to make sure that we find the total current the total current in this circuit generated by this 6 volt battery. Alright, so in order to do that, we notice that this 12 ohms resistor and this 6 is parallel to this 6 ohm resistor, and because they are parallel to each other, what you need to do is to solve the parallel connection to say 12 is parallel to 6 ohm resistor, and this simply means that we are going to multiply this 12 by 6 and also divide 12 divided by 12 plus 6, and the result to this will be 12 times 6 will give 72, and 12 plus 6 will give 18. And when you divide 72 by 18, the result will give us 4. Alright, this means that this circuit can be redrawn, and these two resistors can be replaced with a single resistor. So let's redraw this circuit, and that will be having this resistor, and then we have here to be the 3 ohm resistor, and this is the 6 volt battery. So we have here to be 6 volts. Here is a 3 ohm resistor, and then after solving this we have 4 ohm resistor. Alright, so the next thing we need to do is to find the current in this circuit. And how do we find the current in this circuit? We have to apply the Ohm's law, which says that current multiplying the resistor, which is the voltage drop. So to find the total current, we have I to be, just make it to be I1, alright, which is equal to the total voltage we have, which is V all over the total resistors. So the total resistor we have, and of course you notice that these resistors are connected in series, so that means we'll be having this to be 6 divided by the serial connection will be 3 plus 4, and this will give us 6 divided by 3 plus 4 is 7. And then if you want to divide it and have it in decimal form, it's your choice, but in my case I will just leave it as 6 over 7 ampere. So this is the current that flows through the circuit. So now we found the current in this circuit. To find the current that flows through the 6 ohm resistor, we what we need to do at that point is to say that since this I1 we've calculated flows through this 3 ohm resistor, when it gets to this point, what will happen to it is that it divides to this point and also to this point. So that is to say, we need to calculate for this the current that flows through this 6 ohm resistor. So how do we do that? The first thing to do is to use the current divider rule. And what is the current divider rule? The current divider rule says that I2, which is that current that flows through that I2 or 6 ohm resistor, that will be equal to this I1 we've calculated. We multiply by this 12 ohm resistor divided by the sum of this 12 and this 6 ohm resistors. So we have here to be 12 divided by 12 plus 6. So what will be the result to this? This I2, we have value for this I2 to be 6 over 4. So let's replace it with 6 over 7 rather. 6 over 7 multiplies by, we have here to be 12 over 6 plus 12 will give 18. And then the result to this, if you reduce this, of course, you know that 2 can go into this to be 6 times, and 2 goes into 18, that is 9 times. So 3 will go into this, that will be 2 times, 3 will go into this, that will be 3. So if you reduce this, you notice that 3 also can go into this 6 2 times and into this 1. So we just have it to be 4 over 7 ampere. Alright, so that is the current that flows through this 6 ohm resistor. So we are done with this first phase. In the second step, we need to find the total current that flows through the circuit. And in doing that, remember that in the first step, we had to short circuit this particular 10 volt resistor. So now we're going to bring it back and then shut down this 6 volt resistor and replace it with a short circuit. Remember that if it is a current source, then it have to be an open circuit. Alright, you have to replace it with an open circuit after shutting it down. Alright, so what we need to do is to make sure we draw the diagram. That's very important. That's what we also use in making the analysis. So we have here to be 10 volts, and that's a 10 voltage source, and this is connected with a resistor, 12 ohm resistor. We have here to be a 6 ohm resistor, and also we have here to be 3 ohm resistor. Of course, we've shut down the 6 volt battery and then we just replace it with a short circuit. So here is a 12 volt resistor, and here is a 3 ohm resistor, and this is a 6 ohm resistor. We need to find the current that flows through it. Alright, so here to find the current that flows through this circuit, we observe that this 3 ohm resistor is in parallel to this 6 ohm resistor. So let's reduce this circuit, and then in course of doing that, we have this is our 10 volt source, and then we have this to be 12 ohm resistor. There is a 12 ohm resistor, where this resistor is in parallel to each other. That's to say 6 ohm resistor is in parallel with 3 ohm resistor. So in solving this, you just multiply 6 by 3 and then you divide it by 6 plus 3, which if you go through this will give us 18 divided by 9, and the result here will be 2. Alright, so that means we have here to be 2 ohm resistor. Okay, so in finding the current through this circuit, we just have I1 prime. Keep in mind the other one was I1, so this time we just have I1 prime to represent for the second phase of this calculation, and this will be equal to by Ohm's law, we have the voltage, which is 10 volt, divided by the total resistance, so which is 12 plus 2, and then the result to this will give us 10 over, now we have 14, and this can be reduced to be, if 2 go into this, that will 5 over 7 ampere. All right, so this is what we have as the current that flows through this circuit. But then we are also concerned about the current that flows through the 6 ohm resistor. So in order for us to get the current that flows through this 6 ohm resistor, keep in mind that this I2 prime, I1 prime rather, to go through this direction and also come to this direction. So then we have here to be I2 prime. This is what we're going to calculate, this current through this 6 ohm resistor. All right, so to do the calculation, we have I2 prime equal to, because we're going to use the current divider rule, so we have I1 prime multiplied by, the next thing you have is this 3 ohm resistor divided by, this is 3 ohm resistor I'm talking about, this 3 ohm resistor divided by 3 plus 6 ohm resistor. So we have 6 plus 3, and then this will give us, what is the value we had for this I1 prime? The value we had was 5 over 7, and this will multiply by 3 divided by, this will be 9, and the result to this will be, of course, if 3 goes into itself is 1, if 3 goes into 9, that will be 3, so we have it to be 5 over 21 ampere. All right, so the final step is to use superposition theorem to find the total current. And to find the total current, we have I to be equal to the summation of this I2, which is supposed to be the current that flows through, the 6 ohm resistor, the initial one we calculated, which is I2. So we add this one to this other I2 prime. So that's how we'll be able to get the total current. So we have I2 plus I2 prime. So the values we had for I2 was 4 over 7 plus the one for this I2 prime is this 5 over 21. So if you play around with this fraction, then you notice that the answer will give us about 17 over 21 ampere. You can keep it in decimal form if that is what you want. So this is the current that flows through the 6 ohm resistor. I hope you found this video helpful. Please hit the subscribe button, turn on the notification bell, and help me like this video and subscribe. Thank you for watching.